All right, welcome back to another Chem 1106 lecture. In this one, we're going to be covering the classification of matter. Um, oops, okay, don't worry about those announcements. That was from the previous year. Okay, so let's go over some basic concepts of matter. So remember that matter is everything in the universe that has mass. So anything with mass is considered matter. Um, In chemistry, in particular, we study the composition, behavior, and structure of matter. Um, Mass is defined as the measure of matter in an object, so the amount of stuff that is within an object, that's considered mass. Um, and it can also be broken down into several different categories. So let's go ahead and get some quick definitions down. So remember that elements are specific types of atoms. Um, Atoms are a single type of unit of matter, so it's one of the simplest forms of matter. Obviously, it's not the smallest, as we've discovered subatomic particles and other things like that, but um, it's it's a single unit of matter. Um, Molecules are formed when uh, two or more atoms are chemically bonded to one another. Um, and compounds, on the other hand, are different in that like uh they occur when two or more different types of elements are bonded to one another. So it's a key difference between molecules and compounds, and it's very important to know the difference between these two. I guarantee that something like this will be important in the future, possibly for an exam, but knowing the difference between molecules and compounds is significant. So just remember, molecules are simply two or more atoms that are chemically bonded to one another, and compounds are two or more different elements that are chemically bonded to one another. Um, so in other words, you can identify compounds as molecules, but you can't identify all molecules as compounds. Therefore, every compound is a molecule, but not every molecule is a compound. So in order to discuss these different genres of matter, let's go ahead and start by focusing on pure substances. So all matter is divided into two pieces. So there's pure substances and mixtures, but we're going to go over pure substances first. So a pure substance is matter that cannot be broken down by a physical process, and they have a constant composition. So what that means is that if you were to take a scoop of this type of matter, it would look exactly the same in composition as the rest of the sample that you're looking at. So some examples, like a glass of water, like if it's DI water specifically, um, solid gold that's pure, and like solid silver, pure liquid mercury, or 100% ethanol, all that's considered a pure substance as long as it's pure. A physical process is a transformation of matter that doesn't alter the chemical substance. So often associated with melting, freezing, condensation, sublimation, etc. So that's what a physical process is. So let's talk about one of the pure substances called elements. So an element is a pure substance that cannot be broken down into further, smaller, simpler substances. The periodic table lists all the known elements that you are aware of and that everyone else is aware of. Very few of them actually occur independently in nature, such as like oxygen, nitrogen, silver, etc. And you can also note that there are diatomic elements, but they're still considered elements even though they're diatomic. These can include O2, F2, Cl2, etc. So even though these guys have more than one atom bonded to one another, they are considered elements because they are bonded to themselves. So oxygen, even though it's tempting to say that it is a compound, it is not. It is a element. And yeah, so like if you're looking at these lower examples down here, these are called diatomic elements because of the presence of two atoms that are the same, that are bonded to one another. And then of course, we have these solid elements up here as well. The next one we're going to talk about is compounds. So most elements do not occur independent. Most elements do not occur independently in nature, and instead they take the form of compounds instead. Elements that are chemically bonded to one another, and they can be separated from one another via a chemical reaction. Compounds have fixed ratios. You will notice that more when we go into molecular and empirical formulas later on. And compounds will have more than one element chemically bonded to one another. So like I said earlier, that's what makes it different from molecules and things like that, and elements. Once the atoms bond, they take on new properties and that are different from their individual elemental forms. So for example, CO2, which is carbon dioxide, has different behaviors, different melting points, different etc. than, let's just say, oxygen or carbon by itself. So they take on new properties once they form these chemical bonds. Compounds will not have more than one compound present. So like, for example, CO2, a CO2 compound, if we're talking about solely CO2, that's the only compound that should be present in a pure substance. Otherwise, it'd be considered a mixture, which is what we're about to go into. But as long as it's purely that one compound, it's considered a pure substance. And some examples of compounds include carbon dioxide, water, or ethanol, 100% ethanol specifically, because, right, we can't have other things mixed in with it. Now let's go ahead and take a look at mixtures. So mixtures are divided into two subcategories called homogeneous and heterogeneous mixtures. So what is a mixture? A mixture is any matter that is not a pure substance but is composed of more than one substance. So for example, water mixed with sodium chloride, or all these different M&Ms mixed in with one another. That's considered a mixture. Mixtures are also the physical combination of more than one substance. And in mixtures, substances retain their composition and thus retain their identity. So when you're throwing salt into water, sure, like it separates into ions and stuff, but the water that's in there is still retaining its identity as a water. Substances in mixtures can be separated via physical properties. So like, let's say we had really salty water and we wanted to just get the water out of it and leave the salt behind. We could just heat that solution up to 100 degrees Celsius. The water would evaporate, but the salt would not, and it would stay in the bottom. Okay, so let's go ahead and go into the first kind of mixture, so homogeneous mixtures. So a homogeneous mixture is when where the substances are uniform throughout and do not have a visible boundary. So visible boundary as in like when you mix oil and water, you can see the line of separation. That's not considered a homogeneous mixture. A key thing about homogeneous mixtures is that if you were to take a sample of a homogeneous mixture, that sample would be identical to the rest of the sample that's in there. So some examples include like gasoline, like air in the room, assuming like, you know, there's not a whole lot of dust and other things like that. When we look at this figure right here, we can see homogeneous mixtures could be like steel, rain, some air even. Meanwhile, heterogeneous mixtures are not uniform throughout, and I'm about to get into that. So heterogeneous mixtures, they're often opaque, and that means that they're not clear, and generally have like tiny insoluble items floating around in it. So you could think of it kind of like a soup in which has like a bunch of different things floating around within it. Um, they sometimes are not clear because they will often have like tiny things floating in them, like within milk. Milk has a lot of fats that float around, giving it that white color. Um, they can also be separated, such as the way that like oil separates itself from water in salad dressings over time. Hence, that's why you need to like mix it or shake it. And also, human blood is red and opaque because there are tons of like red blood cells floating around throughout the plasma, and that would be considered a heterogeneous mixture because it's not uniform throughout. There's going to be bits of like white blood cells, red blood cells floating around in blood that make it not homogeneous. And like I put a picture of the seawater here because if we're talking about seawater, if we take a scoop of seawater and we look at it, there's probably microorganisms floating in there. There's probably bits of like, I don't know, debris, seaweed, whatever. It'd be considered a heterogeneous mixture because every time you scoop a bit of seawater, you might get something different. It's not going to be the same as the, the rest of the sea. So it'd be considered heterogeneous. And briefly, let's go over the difference between chemical and physical changes because they're important to know. So a physical process is a transformation of matter that doesn't alter the chemical substance. These things could be associated with things like melting, freezing, condensation, sublimation. So like all the different forms of phase changes, as well as the act of shredding paper or like cutting up objects, etc. Anything that doesn't chemically alter the substance is going to be a physical process. Meanwhile, a chemical process often involves the breaking and forming of bonds. So you're going to get something different out of it. So this is not like a physical process where the physical process occurs, but you still have the same exact thing that you started with. So like in ice, when you melt ice, it's still water molecules that you're working with. However, in chemical processes, this is not true. So like a good example I like to use is like when you're boiling an egg. The chemicals in the egg itself change in a way that can never return back to its original state. Same thing with burning paper. The act of burning something is considered a chemical process because it is an a redox reaction. It's an oxygenation reaction that occurs with the oxygen in the air and the different substances that make up paper. So you're going to get something different out of it. And like when you are burning paper, you release carbon dioxide along with other gases that come along with it. So the key takeaway is that a chemical process involves the breaking and forming of bonds. So you should end up with something different. And just to quickly summarize, here's a little chart that I like to use that will help you identify what type of matter you're dealing with. So you would start from here. All matter, can it be separated from a physical process? If yes, you go this branch, and if no, you go down this branch. And then, for example, in element, you have pure gold, right? Because it's pure, it's only the element's gold that you're working with. So that will be an element. If we're talking about a compound, there's water, H2O, so 2 hydrogens bonded to 1 oxygen. That's considered a compound because a hydrogen and oxygen are different elements that are bonded to one another. A homogeneous mixture, vinegar. So it's uniform throughout. If you take a scoop of vinegar or a teaspoon of vinegar, it's going to be basically identical to the rest of the vinegar that's in that container. And then a heterogeneous mixture, such as salad dressing, things are going to separate. The oil is going to separate to some extent. There's going to be lots of other things that are like floating around. And like if you were to take a scoop out of like salad dressing, you might get mostly oil one scoop, and then in the next scoop you might get a ton of different other things that are in there. So it's inconsistent with what you're getting. That would be heterogeneous because it's not uniform throughout. All right. And that should be it for classification of matter.